So here's my completed project. Not going to get me into the Guggenheim, but it works. It will get me 100 in calculus, and that's what I'm after here. All right, that's all we need to do. So a little bit about the reason for this project, right, is that these cross-sectional volumes are quite difficult to visualize and to draw. So that's why it's advantageous to make a model of them, and that's basically what this is. Remember, this is the model of a solid, so you really want to imagine that it has solid sides here. And if anybody can actually construct one of those, that would be super awesome, but I think it's probably pretty difficult to do. I've never figured out how to do it, but if you could make it into a solid, that would be superb. There's in the rubric, the sort of subjective claim is that you have to have enough triangles or enough cross sections to establish the solid. So I'm not giving a number for that because it depends on what your solid looks like. So this is a sufficient number that I can see what the solid looks like. If I only had 3 triangles, I would not know what the solid looks like. That would be insufficient cross sections, right? Now, so that's a word about that. What you're going to turn in is a photo. So, take a photo at like an angle that shows the 3D-ness of it. But I also, because it's 3D and it won't just show that in a photo, I want you to submit it could be a very, very short video. It could be like 3 seconds where you just take it and like sort of show it from different angles so that I can see the 3D-ness of it. That's it. So just like, here's what it should look like. Done. Okay, because I know that people have probably data issues and Wi-Fi issues and all kinds of things. You don't need to submit me, a 5-minute video about your project. Just show that it's so I can see that it's 3D. I can see the 3D-ness of it. Just a very short video. Okay, and then what do we need to do to finish up? We need to then actually calculate the volume. So you need to show the area of the cross section. So how did I know that the area of an equilateral triangle is square root 3 over 4 s squared? Because I looked it up. So you can feel free to look up the volume of whatever cross. You can use any cross section. You use like pentagons or something. You can use anything. If you use something we've not even talked about, that would be very cool. You could do that, and then just use the same. You just find the area and then you integrate it. Okay. I wrote in here what the side length of each triangle is, and then I gave the volume as an integral. I stated the integral in complete form here, and then I just gave the value. I calculated it on my Casio, so I said integral value approximated by Casio Prism calculator. Just say what you used to approximate it. You do not have to do the integral by hand. You could get kinds that could be done by hand. This would be impossible to do by hand. I can't think of any way how you would do that. All right, so that's basically what's required on the project. I thought maybe I'd take a little time and say how we could do sort of some different shapes, in an efficient way. Let's say I was doing right triangles with the leg in the plane. So I could do, one thing I would do is I'd like to take advantage of this corner, but I really can't because I have to have tabs to support the triangle. So I thought what I would have to do is mark like a 0.5 centimeter in on each side. Mark like a 0.5 centimeter in. Actually, yeah, that's 0.5 centimeter. And then that way I can just get a nice straight line all the way across that is parallel, that's still perpendicular to the edge is what I need, right? And then for each triangle that I'm cutting out, I can really just go like that. And then, you can measure. There's lots of different things you could do, but another thing I could do is use a compass. See, I love my compass. Do things with a compass. It's good to have a good compass when you go off to college. All right, and then there you go. So I'm going to mark it down here. Oh, and know how to use it is always a good thing too. And then we can connect these up. Shabing. And then I got my nice tab here and I cut it out. Right. What if I want to do semicircles? Semicircles are a little tricky, I think, because of the tab, but I would do sort of the same idea. I would mark out one long tab for the whole thing, and then if I wanted to do a semicircle, I would... so the tricky thing is going to be that you only have a diameter here, and you need a radius to put semicircles in there, right? So how am I going to find the exact center? Well, the first thing that I'll do is the same trick that I did for equilateral triangle. Mark here and here, And see because what that also gives me is a perpendicular bisector. So that'll give me the exact, it'll allow me to construct the midpoint. So I mean, I could do the same thing sort of over here and make a corresponding arc and draw across. That's a little extreme for me. So I think what I'll do is I'll just use the fact that my ruler has a right angle on it and use that to have a pretty good right angle here. And then see, this is like just a center point, and then I can just mark that center there. And then I can reset my compass and do the semicircle that way. So ding, 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 ding. I get it, small it down so that it matches that mark there. And now if I do my semicircle, it should nicely fit. That was a pretty good fit. Yeah. Other shapes, what if I want, if you want the diagonal to be in the shape, so you can, from there, sort of figure out a lot of different things you can do. You can figure out whatever cross-section you want to use. If you want to use squares, like that's pretty easy to make a square, right? So decide what you're going to use and make a nice project. Write it up. You don't have to type it. You can just write it. And that is the first part of the volume project. And I'm thinking I'm going to add in a second part. But this is the part that I needed to demo for you.